Good afternoon, everyone. Thank you very much for taking the time and coming here to hear me speak about something, right? So this session, as you can see on the screen, we have three major topics that we are going to try to cover. So we are going to talk about domain-driven design. We are going to talk about how composable architectures, which is an outcome of a state on which your architecture is going to look like, and how DynamoDB, how we can use domain-driven design to find the access patterns that are required when you design efficiently for DynamoDB using single table design. Before going ahead, so I'm going to ask you a quick question. How many of you identify as working with enterprise companies? All right. Keep your hands up. I'm going to define what my enterprise is according to my definition. So an enterprise is essentially a company where you're using software to support your main products, right? So maybe now you can change. Again, that's a little bit of a different definition, but it is. So software is never your main product, but you're trying to sell something, right? So for example, I work at Polestar. We are an electric car manufacturer. So my main product is always how can I sell the car more? So I'm going to use my software to make sure that the car is beautiful. I'm going to use software to make sure that it is reaching in most of their hands, right? So this is my definition of enterprise, let's say, companies. So if you have worked in enterprise companies, and if you are a persona which belongs to things like an architect or a business person or a technical manager or stuff, you'll go to a user acceptance testing with your users or your customers, or like if you're in a setup where you're selling or where you're helping other companies build software, they will say, when you do a demo, they're like, nah, this is not what I wanted from my software, right? Or why are we investing so much time, money, and effort in building something that I can actually buy off the shelf? There is already certain product available on the market, right? If I flip around the persona, and if you go to a builder persona, you will see that during sprint planning or when there are tickets being applied or given to these developers to build something, they're going to say, this ticket looks too vague, or there is not enough details in there so that I can basically tell you how much time I'm going to need to implement those details. If you are in a company, in a setup where you are, let's say, already using DynamoDB, you will also hear excuses like, it is not so clear, so I cannot define my access patterns, so we cannot use DynamoDB, let's find something else. I have transitions from the builder persona to the other side as an architect, and I often got these, let's say, comments, and this led to me doing a little bit of a deep dive. I asked a question to myself, why do I see this pattern recurring across startups, in medium-scale companies, in enterprises? So I said, let's see if there is something out there that can help me. Typically, what happens is when in an enterprise setup, when you have these kind of problems, you will see that the company will try to hire an agile transformist or some sort of a person who says that using X agile framework is going to solve your problems. But really, it is not. The core of this problem is there is too wide of a gap between what the business wants or your business user desires and the understanding of what the business user needs amongst the common developer. So I asked this question, what can I possibly do? What can I as a person can possibly do to minimize the above issues? So I went down a rabbit hole. I tried to look at different, let's say, frameworks. I tried to look at different agile delivery methodologies. I dived deep into SAFe and all of those things that were really fancy, but they were software delivery methodologies, right? We were still not spending enough time on the design phase of the software. So this is where I found out domain-driven design, and I spent a whole 6 months reading the literature and books, and I thought that this was the thing that was missing that I didn't know as a person, as an engineer, I should have known during my progression. So if you take domain-driven design, apply its principles, and take the suggestions that are provided by domain-driven design, you will end up in a state in which you will never have a monolith or one piece of software that is going to solve the problems that you have in your organizations. Rather, you will have a disparate set of different softwares. It could be a combination of monoliths, microservices, service-oriented architecture, or whatever the things it might be. And this state, when you have divided your software into multiple pieces, which is doing a very specific task, that's composable architectures. All right, before we go there, I should introduce myself, right? Where are my manners? So who am I? I am Anurag, and I work for a company called as Polestar Cars. And I work in the digital department, which basically means I help deliver all the customer software required for the customer touch points, as well as the supply chain, let's say supply chain software, ERP, yada, yada. I work with all of those. My official title in Polestar is I'm a cloud software architect, and my job is to help the Polestar to run software on the cloud. I'm based out of Gothenburg in Sweden. That's the second biggest city in Sweden. And I have progressed from being a user group organizer, and then I have ended up actually being a data hero, and I have been a data hero for the last couple of years. So what are we going to talk about today? I'm going to take you into a little bit of a journey. I'm going to introduce you domain-driven design. I'm going to introduce some of the theory and some of the core concepts that are required in the domain-driven design area. We're going to see how applying domain-driven design to your context is going to lead into a state which leads to a composable architecture state. We're going to talk about Amazon DynamoDB's single table design philosophy and why do we need it. And then using the outcomes from our domain-driven design exercise, we are going to use something called as aggregates, and we are going to use these aggregates to find the access patterns that are going to help us design the domain-driven design. They're going to help us do the single table design effectively. Let's dive deep into domain-driven design. Let's start with an obvious disclaimer that I need to make. Domain-driven design is often confused with the agile methodologies or delivery methodologies. It's not. It is all about design phase. It's all about what we need to do before we even write the first line of code in a software. People will also say, okay, I'm in a brownfield project, I really cannot do that, but I have found this particular methodology much more effective in brownfield than in greenfield as well. I'm not saying greenfield cannot be done, but it is much more effective in brownfield as well. So here's the definition that I find of domain-driven design that is really, really good. Domain-driven design basically is a collection, or it provides practices for a collaborative approach, wherein it gives you the ideology on how I want to interact with the business users, how an average developer in my group can talk to these business users, and we ensure that they are getting what they want. So in a high level, domain-driven design is a 4-step process. The first step is you look at your business strategy. It's quite obvious, I know. But understanding the business strategy is really, really imperative. Where is the business going next? What are the components of your business where applying technology is going to add value to the business? Once you identify those components, you're going to engage with the most important stakeholders in those particular areas. You bring the stakeholders into a room. You try to have a discussion. That room typically should consist of all the personas from business side as well as technical side, and we try to create what we call as a model of the software. Now, this model is just a representation of business rules. It is a representation of what the software they are desiring. It's in a language that is familiar for the business users, and we are going to try to use their language to inculcate those hints in our coding practices. And finally, when you build this particular model, we are going to use it to build the software. There are 2 phases in domain-driven design to building a domain model. The first phase is what is called as a strategic kind of phase. This is where you are going to try to understand the business areas and try to create a state or try to find what are the different business components or business capabilities that you are going to need to deliver that particular value. You'll do this by first starting with finding the subdomains in your business. Then we will document what we call as ubiquitous language. In short, ubiquitous language is the same language that the business uses when they are using the particular software. We are going to identify bounded context, which are going to serve as an input, and it is going to help us build a context map, which basically tells us how does these different subdomains need to interact with each other. Once you do this strategic DDD exercise, we will start what I call as tactical domain-driven design. And in this, this is not the full representation. I've limited this for the database areas. So what we are going to do is we are going to take the context map and trying to find the entities that are involved in these areas. So entities, I'm going to define them later. We will find what we call as value objects. And using those, we are going to finalize aggregates. And these aggregates are going to give us the input on helping us find the access patterns that we can use for domain-driven design, for DynamoDB single table design. The strategic DDD gives us hints on what is the right thing that we need to build, while the tactical DDD gives us the idea of how to build this thing right. Subtle difference, but very important. I'm going to spend a few minutes to introduce you some theory, and then we are going to go into an example which will make these things a little bit more concrete. So in strategic DDD, what we are going to do is we are going to start with understanding the subdomains. So there are 3 core ideas of subdomains. There is something called as a core subdomain. So this is something, or this is the part of the software which your company does differently, or this is the area which is going to give you a competitive advantage. There is something called as a generic subdomain, which is basically something that each and every company does. It is still complex, but it does not provide you any competitive advantage. A classical example is accounting. So accounting everybody needs, but you having a fancy accounting software and having a software that just works is not going to give you any competitive advantage. And there is something called a supporting subdomain, which, as the name suggests, it supports the business operations. It is low complexity in most of the time and does not provide any competitive advantage. When we take these different subdomains and map it on an axis of complexity versus the differentiation that it creates in the business, you will see that generic subdomains are at high complexity level, but they are not providing you a lot of differentiation. So what you should typically do is when you have identified the generic subdomains, you should just buy commercial off-the-shelf products that you can just use, get started, do it quickly. For core subdomain, this is the differentiator. You should be spending most of your time in your software building this core area because this is something that is going to differentiate you from your competitors. A classic example is if you are a taxi sharing service, your algorithms which is going to define which area should the drivers pull around so that their chances of finding a ride is maximum in certain areas of time. This gives you competitive advantage over your other competitors. So you should definitely build this in-house and invest time and resources on it. For supporting subdomain, you should basically outsource it because there are companies which have already solved these problems. And then there is some weird software that is always going to fit between generic and supporting kind of, let's say, definition. For this, you make a tactical decision whether you could use open source or you could basically decide to either outsource or buy. Now, once I have made all of these areas, what I need to do is I need to find ubiquitous language. The definition of ubiquitous language is really simple. It's a glossary of terms that the business is using while using the software. So this basically, it enforces that the business and software are talking the same language. It also makes sure that when I am talking to the business users, I'm not using any translations. It also tells, or it helps us capture the mind that the business users have and their mental models on how they are looking at this software when they are interacting with it. And it basically eliminates the need of assumptions. For example, if you are in a ticket purchasing business or ticket selling business, if the person who is selling the business always uses the word that the customer has purchased a ticket, then all of the variables or functions or all of those naming conventions in your software should basically say that, okay, ticket purchased is something that you refer, so that an average developer, when he or she or they interact with the software user, they know they are talking the same terms. Bounded context, it's basically when you have the ubiquitous language, you're going to try to group it together and going to try to find the business process in which those ubiquitous languages belong. It is a collection, and you will apply it is a collection that is applied to a specific context. For example, if you take an account and if you put it in a library context, it's going to mean different than it is going to be for a bank context, right? I hope there is no software as weird as this which is catering to both of these exist, but it makes the point. So once we have done this, we are going to try to build a context map where I will have multiple bounded contexts. And now I'm going to try to define how these bounded contexts are talking to each other. So there are 7 different models in which these bounded contexts can talk to each other. One of them is partnership, wherein basically, which means the bounded context 1 and bounded context 2, they're going to sit together and define how they are going to interact with each other. This is required when there are 2 pieces of software are equally important in your area. But then it's unequal, so there are going to be software where one software is much, let's say, important than the other. In that case, you'll have a conformist kind of relationship, which basically means that the upstream, which in this case is bounded context 1, is going to dictate the terms, and the downstream, which is bounded context 3, is just going to figure out a way on how I'm going to use the data given by the bounded context 1, and I will figure out how I can consume it. So in this case, the conformist and the upstream is going to enforce the details. There will be some areas in which you will have, let's say, a business where there is an overlap. So you may decide to, let's say, build things like a common SDK and stuff. So that's a representation of shared kernel. And then there is also something called as a customer-supplier kind of relationship, wherein these bounded contexts 2 and 4 in this particular case, the upstream and downstream, what they are going to make sure is every time you make a change, you are going to have to ask the customer, okay, is it affecting you? And I'm going to take the cues from there to ensure that I'm not breaking the contracts. There are a few more of these, like 3 more, which are like anti-corruption layer and stuff, so you can look them up later. They are not important for this conversation today. All right, enough of the theory. Let's take a hypothetical example and let's try to apply this and see what output do we get from there. So let's take an example. This is a room. So let's say this room belongs to a co-working space, and this is the only room that the co-working space is available. This is really beautiful, and everybody in this co-working space wants to book this particular room when they want to use it. So to build a software that is going to help you, let's say, manage this room booking system, there are going to be something called as functional requirements, which is basically the things that software needs to do. So the functional requirements that are given to us is that this room, this single room in the facility, I should be able to book it. I should be able to book it for a time, let's say a single room for 30 minutes or 1 hour slots. I should allow for cancellations if there is a change of mind. And then there are some non-functional requirements which generally comes from audits or they come from compliance areas, which we are saying that, okay, we should have analytics on top of it, it should be auditable, and we should ensure that the people who are booking it, they are paid users of the co-working facility, right? So to get this out of the, let's say, to build a software like this, I'm going to do a discovery phase or I'm going to do a design phase, wherein I'm going to bring in the facilities manager or the office admin or the personas who are actually working on the floor of this co-working space who are managing this facility. And I'm going to ask them, okay, how is it that you are doing the bookings at this moment? So they will start saying that, okay, a user comes to me and they tell me that they want to reserve a room for 30 to 60 minutes. So in this case, and they should be able to check in and check out during this slot. So if you observe carefully, I have let's say, highlighted the words reserve, room, slot, and check in and check out. So these represents the actions, this represents the words that these users are using. At the same time, a compliance person comes in and say, I should be able to audit the entire activity that is happening in this software. So you're going to try to bring in the facilities manager, office admin, compliance, software architects, your infrastructure architects into the room and try to make a conversation. And the output of this conversation would be a glossary of these terms, which is going to indicate what are the stuff that we are talking about. So here in the example, reserve is a verb, which is a representation of an action, right? But at the same time, the things like room, slot, cancellation, these are nouns. So these are representing an object that the object that I have in the software. We take all of these languages, and what we are going to now try to do is figure out which of these actions can be grouped together in a semantic way, which is basically, we will say that, okay, room reservation cancellation slots, if a business process kind of happens. They are all in the same context. At the same time, if I'm performing actions like check-in, check-out, and reserve, they are also in the same context. And the function of the process of doing a check-in and check-out is you find that they are all representing a single business transaction. So we can say easily that all of these actions that I'm performing, they are part of the reservation, let's say, ubiquitous language group. Similarly, for analytics, we have a record, which is basically a, let's say, trail of events that is happening in the reservation. And for security, I'm doing identification, authorization, and auditing these logs. I'm going to take this ubiquitous language next. I'm going to now define what are my subdomains. So in this case, you will see the reservation is something that is giving me a core, let's say, it's giving me the competitive advantage here. So I'm going to say that the reservation domain is going to be my core subdomain. So I need to build this in my own company, or I need to build this in-house. There is going to be an analytics kind of, let's say, thing. Everybody does it, right? Everybody has it. So this is a generic subdomain in our use case. And then there is security, which is supporting subdomain. Now we are going to take these next steps, and when we took these words together, we found that the act of doing reservation is a smaller piece of software that I can build, and then I need to build a display logic. In the analytics subdomains, I'm not doing much more than that, so I'll have only one subdomain, one context in it. And then in security, I'm gonna need two things. One is user management, and one is for auditing things. Now let's define how they are going to interact with each other. So the reservation and the display, they are going to have a customer-supply relationship, because the moment you break API contracts, the display is going to go down, right? So you need to, so the teams that are developing reservation and display, they need to have a customer-supply relationship. At the same time, analytics and reservation, they are going to have a conformist relationship where the core subdomain is basically the upstream, and the analytics is downstream, which basically means the analytics are going to figure out when I get the data from this event, they're going to figure out a way to get it transformed in the way they like. For security supporting subdomain, which I'm generally going to buy it off the shelf, there is going to be a published language kind of, let's say, relationship, which basically means we are going to use a well-defined set of APIs to interact with each others. Right, so this is the state of the software, which indicates that I'm going to have 3 different deployments, at least 3 different deployments, or I could have like 4 teams that are going to build these different areas. This means that I have, this is the representation of the first composable architecture for our use case. The example is trivial, but the moment you apply it for a bigger business case, you will get a much complex context map. Now I have the context map. Now I've decided that, okay, I'm going to concentrate on my reservation domain because that's my core competency. I need to build that. Let's try to apply tactical domain-driven design principles on top of it. So the 3, let's say, the 3 components of tactical domain-driven design that we are going to look today are called as entities. Entities are basically the objects that have a life cycle that you are trying to track in your software. In my case, it is a room, so that's an entity. There is going to be a value object, which is going to be a definition, or it is going to be supporting attributes that are going to define or give extra meaning to the entities. These do not have an ID, or they do not need to be, we do not need to track their life cycle because they are only enhancing the values of an entity. And the final thing that we are going to look at is an aggregate. So aggregate is basically when you take the entities and value objects, you're going to create a cluster of these entities and value objects. This cluster is going to represent your business process. Any interaction with these, any interaction with the software needs to happen from an aggregate. So this aggregate is going to ensure that whenever you are interacting with this, every transaction happening inside of this aggregate is going to be a unique transaction. So this is equivalent of doing transactions in the regular software language world. So if I take this tactical DDD terms and we apply to this example that we just saw a few minutes ago, what I'm going to look at, what I'm looking for in the reservation aggregate is I will see that I have a reserved slot root. This is the root aggregate, which basically means this is the aggregate that the software is going to interact, and this is going to change the areas. This is going to change the other attributes that are available in my aggregate. I have a slot entity which represents the different slots in my room that I can book. And I have something called as a time slot, which represents the 30 minutes, 60 minutes different time slots that I can have in my software that the customer can book. I'm going to take this reservation aggregate, and I'm going to find how they are related with each other. So this is your general UML kind of thing. So this is still not database, let's say ER diagram or stuff. This is still a pure representation of how the business is looking at different aggregates, different entities. Now, when I have this kind of things ready, this will be well documented somewhere in my document, let's say areas, which will ensure that when a new person is joining this particular team, or if somebody leaves, the knowledge is always intact in your company. You are not going to miss that knowledge, and you have a very good documentation that is going to be, let's say, never going to go away anywhere. So it ensures that your software is perennial. Right, now once I have found these aggregates, what I'm going to do is I'm going to use aggregates to find the access patterns. So in our case, if you look at it, we had two data objects. We had reserved slot and we had slot. And the way they are interacting with each other is there is one-to-one correlation. So if a software is performing a reserve slot action, it's going to change the slot identity. But the time slot object that we had, it was just a collection of an attributes. So I do not need an entity of this in the database. So it can be just an attribute attached to the to my database. All right. So far what we have been able to achieve is we took our business strategy. We found the different components. We found what are the areas in which I'm going to invest most of the money. I found out which are the areas in which I'm just going to buy off the shelf. Now what we are going to look is I've decided, okay, the reservation, let's say subdomain is something that I'm going to build in, and I'm going to do that with DynamoDB because that's my company uses. So when you're working with DynamoDB, you need to know certain things about the single table design, and this is the principles. I'm going to quickly introduce what single table design is now. So Amazon DynamoDB, as you know, is a purpose-built NoSQL database, which is a distributed database behind the scenes, which means that instead of adding more RAM and compute and beefing up your CPUs, what DynamoDB does is it adds smaller clusters and it's spread across the database. It spreads the data across multiple regions. When they designed DynamoDB, they made certain design decisions. So they gave up certain aspects. So they designed it for performance at scale, which means they had to give up certain things, certain trade-offs. They had to make certain trade-offs to get this kind of performance. And these trade-offs basically indicate that we will not have joins, we will not have constraints, we will not have typical stuff that you generally associate with relational databases, which is so to make sure that we can get the best out of DynamoDB, what we need to do is use a single table design principle. So single table design is basically an opinionated way in which you can structure the data structure on how you are going to store the data inside of this. It is based on the fact of select denormalization. What I mean by that is when you do database in third normal form, that's what everybody knows generally. You try not to duplicate data, but single table design says don't worry about duplication because storage is kind of cheap these days. Let's make strategic choices where we can duplicate the data so that it can facilitate the way the software interacts with the database. It also enforces that the schema needs to be aligned one-on-one with your access patterns. So access patterns are basically things on how you're going to use this database. A quick introduction of the terminologies. So here's how a typical DynamoDB single table design looks. So the first change that you're going to look at is at the top, where you typically see things like customer ID or order ID as the primary keys. Here you will see that it's a generic name called as PK and SK. So what I have done inside here is, this is the combination of PK and SK, which is just a partition key and sort key. It creates a primary key for my table. So here you will see in this particular example, order hash some number and product hash some number is representing a one-to-many relationship in this area, in this diagram. Sorry. You can only use the partition key and primary key to do filtering operations in DynamoDB. So when you use either a PK or an SK or just an SK or just a primary key, you will be able to identify one row inside of your table. So this is called as an item. And then when you are just using a partition key and you get data back from the area, it's called as an item collection. And this entire, let's say, item collection, so you can have more than one item collections in your table. This constitutes a table. So that was a quick introduction. Now what I'm going to do is I'm going to use these principles and we are going to apply it to the aggregate that we built a few minutes ago. So in this case, I have created an aggregate called as, not an aggregate, an item collection called as reserved slot. And this reserved slot is basically indicating that when a user interacts with this particular software, they are saying that for a particular slot, I want to book it and what kind of, let's say, slot I have booked, and I'll be able to track that inside of the software. All the logic code required to do your ACID kind of compliance has to be maintained inside of your code. DynamoDB does not do that. If you do it this way, DynamoDB guarantees that you will get consistent performance, which is generally less than 10 milliseconds on every API interaction that you are doing with the table. At the same time, reserved slot is the only way in which the software can interact with the external agents can interact with this particular software. Behind the scenes, I also had another entity which was basically called a slot, and this slot is something that I have tracked now as a separate item, and then I get a collection of all the slots that I can let the customers book behind the scenes. But the act of booking only happens to the reserved slot, which was our entity, which was our aggregate root. All right, then if I bring back the context map from the previous, let's say, from the exercise that we did a few minutes ago, we had the reservation, display, and what we have been doing so far is we have defined the reservation context and how the DynamoDB is going to look like in that reservation context, which means that there is going to be one DynamoDB table that is representing the software transactions that are happening inside of the reservation. Now, let's say for some reasons I said that the auditing software is something that I'm going to build. It's going to have its own table. There is a big confusion among the people when they're using single table design that for all of the software, I need to have one bulky single table. That's not really what single table design represents. Single table design represents the use of selective denormalization so that you can get best out of DynamoDB. I have seen enterprises do this mistake of creating one big bulk of database and try to put all of their aggregates into a single table, and that leads to multiple problems, which is basically then you cannot apply things like different read capacity, write capacity units on this table if you have one single table, because there are going to be some partitions that are hot, some partitions that are not used. So having single table design, please note that it doesn't mean that you should have one big, huge table for your entire software. It's okay to have multiple different tables in your context. All right, so when we do all of this exercise, let's say this is how the architecture is going to be. Again, it's a representative architecture. Don't take it too much to the heart. This is what we have achieved so far. So what we did is we achieved 3 different pieces of deployments, 3 different life cycles, 3 different teams, 3 different areas are as a representation for the software that I wanted to do for my room reservation, which means that I can optimize each of these areas as desired as the interaction patterns changes, as well as when I have a DynamoDB in all of these different areas, I can apply, I can change the DynamoDB parameters to fine-tune them separately out of these areas. So you don't have one team that dedicated to one to this entire area, but you have different pieces of software that then you can individually optimize, individually operate, and individually use for your software work. Let's take a quick another example, which is a parking system. So in a parking system, let's say you have a ticket vending. Let's say ticket vending, let's say either an app or a tablet, and it's doing actions like it is creating invoice, refunds, discounts, and payments. You will also have something called as a renewal and session kind of things, because the parking system also wants me to do all of these areas. Now, when I apply this, when I create item collections, when you apply domain-driven design principles on this, what you will find is the ticket vending or the ticket entity is interacting with invoice, refunds, and discount, because all of these actions are dedicated to one ticket, which is independently available. So what you will end up having is one table that is shared between these two contexts, because the representation of in the single table design, all of the entities and attributes inside of these two are connected to each others. But on the other side, you will see that the parking, renewal, and session management areas are disparate. They are not associated with the other two areas. They are not associated with the same business process as just doing ticketing and invoicing. You can have a second dedicated table for these areas. So in summary, this is what I want you to take away. So domain-driven design is a principle, is a framework. It's not a software delivery principle. So it helps you build business-aligned software. If you find the subdomains, it can help you align your investments to make sure that you are investing in the right areas, building things that are differentiating you, and aligning aggregates with your, and having a well-defined aggregate is going to help you design the single table design very effectively. Final note, these models that we have built as an outcome of domain-driven design, they are evergreen, but none of the models are always going to be true, but they are going to be very helpful in the longer run. I like this quote from George Box, which basically says all models are wrong, but some of them are useful. Models are always going to ever evolve. Having a place where you have all the models of your software there and you are evolving the documentation is going to ensure that the drift between the documentation and your software is as minimum as possible. There is definitely no way of eliminating all of those. With that said, thank you very much for taking the time. Please take a few minutes to give you a survey of this particular sessions on your mobile app. If you want to ask me any questions, I will be around either at back or outside. And if you fancy talking to me after, you can connect with me on LinkedIn or X or erstwhile Twitter. Thank you very much.